The result from equal sharing of electrons in a covalent bond is known as, I told you, we'll classify covalent bonds into two. So one is polar, the other one is non-polar. So do not forget, today Academic Daddy will continue to teach you everything on chemical bonding. Like, share, and subscribe. So that question 11, the answer is going to be, if it's equal, it means it's non-polar. It's non-polar. 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 So equal sharing of electrons in a covalent bond is non-polar. Examples include when I have H2, they will share the electron equal. When I have Cl2, they will share the electron equal. When I have O2, they will share the electrons equal. So these are polar, non-polar covalent bond. Once it's sharing equal. Now the result from unequal, when it's unequal sharing, unequal is polar. Once you hear polarity, you know it's talking about positive and negative. So once you hear polarity, you know it's talking about positive and negative. So when it's polar, it means one side is more positive or one side is more negative. So it's not equal. So it's a polar covalent bond. Polar covalent bond. Polar covalent bonding. So the result from unequal sharing of electrons in a covalent bond is known as polar covalent bonding. This one is non-polar covalent bonding. Now, number 13 question. Now, an example of polar covalent bond is, for example, when I have HCl. Notice that in HCl, I have 7 electrons in the atomos shell of chlorine and just 1 for hydrogen. So because there is so much electron in the atomos shell of chlorine, it will tend to be more negative, and as it's dragging the electron, it will leave it to be partially negative, and this particular one, which is the hydrogen, it will leave it to be partially positive, because the effect of its negativity is not as high as the other one. So it's as if it's slightly negative to this particular one, which makes it partially positive. So you need to know that that's a perfect example. Now let's move to when I have the question number 13. So this is an example. Now, electrons can be divided into dash and dash. So electrons can be divided into valence electron and the core electron. Make no mistake about this. Don't confuse this with bond pair or lone pair. So don't confuse it. So when it's about electron can be divided into valence electron and core electron. What valence means is valency. You know that valency talks about combining power of an element. So valency, when you say valency, means it has electrons in the atomos shell. And when you have electrons in the atomos shell, it shows that you can use it for something. So in that case, when you hear valence electron, it's also called bonding electron. It talks about or should I say elements, or should I say valence electron. Valence electron are electrons found in unfilled uh, atomos shell, or you say in unfilled orbitals. So it shows you that some configuration needs to be done for stability to be achieved. That is octet's rule to be obeyed. Why core electrons are electrons found in complete orbitals or in complete outer shell. So that's what core electrons are. So now there's a difference between lone pair and bond pair. So the major difference, you need to know that when you talk about lone pair and bond pair, know that you're talking about Lewis theory, or you call it Lewis structure. So lone pair are those ones that come in such a way that the dots are 2. So he has no business with bonding with another one, except when you are through, when you've seen that you've been able to exhaust your bonding pair. Why bond pair are those ones that naturally come single. When you see the dots, coming single is alone. That means it has to take parts. Remember, I'm talking about bond pair. It has to take parts in the combination. So this is what bond pair looks like. It has to take parts in the configuration. While lone pair does not have need to take parts. It only takes parts when it's given to. It only takes parts when it's given to an element that is on field, is helping it. But this one must take part because it is present. It will be present to show that configuration needs to be done. So that is for lone pair and bond pair. So we move to the next question, question 13. Question 13 says, the table below could be used to find the type of chemical bond. We already know what electronegativity is, measure of attraction an element has for the electrons of another element. So when we see this difference, when a question is given to us and they give us En, it means electronegativity. So anytime your En value is less than 0.5, just know that the lesser the value, uh, the more equivalence there is in sharing or transfer or whatever they are doing. So when it's less than 0.5, it means it's non-polar. When it's less than, when the value given to you, a question can be given to you, they tell you, for example here, what type of covalent bond is formed in the following compounds. They give you En. This En stands for electronegativity. So once you see this kind of question, know that if the value you have after subtracting is less than 0.5, is non-polar covalent bond. And if it's between 0.5 to 1.9, it will not be equal to 1.9, but between it, you know that is a polar covalent bond. And if it is from 1.9 equal to it and above, know that it is an ionic bonding. An ionic bond. Know that is an ionic bond. So notice that together, these two gives us covalent bond, because that's how you classify covalent bond. The effect of covalent bond brings about whether it's polar or non-polar. As we progress, you still hear, when we start treating organic chemistry, you start to hear things like pi and sigma bond. So now let's move to this one. They say, what type of covalent bond is formed in the following? So in the following, notice that I have 3.00 and I have 2.1. All I need to do is to say 3 minus 2.1 is the same thing. 3.0 is the same thing as 3 minus 2.1. So if I remove 2 from 3, I'll have 1. Now if I remove 0.1 from 1, so this is the same thing as saying 0.9. This is the same thing as saying 0.9. So when the value is 0.9, 0.9 is less than 0.5. Shebi, is it less than 0.5? Check. So 3 minus 2.1 will give us 0.9, and 0.9, is it greater than 0.5? Yes, it is. What am I saying? Yes, it is. So if 0.9 is greater than 0.5, that means it is going to be a polar covalent bond, because it is going to be polar covalent bond. It's polar because of the fact that it's 0.9, and 0.9 is in between 0.5 and 1.9. So it's polar covalent bond. Now let's move to Cl2. Cl2 is the sentinels, and they are giving us electronegativity of Cl chlorine to be 3.0. So this is the sentinel saying 3.0 minus 3.0, which will give us 0. So is 0 less than 0.5? Is 0 less than 0.5? Look here. So if 0 is less than 0.5, this means that this is non-polar, and automatically, even without the values given to you, when you see H hydrogen and you see Cl, you will notice that somehow this is having 1 electron in the outermost shell, this is having 7. So it tends to have much more negativity than when compared to this one. So this one will be partially positive and this one will be more negative. So in that case, automatically it's a polar covalent bond, polarity. While when it is equal, the sharing of electron here is going to be equal. And when it's equal sharing, there will be no partial positivity or partial negativity. So it leaves us with non-polar covalent bonds. So down to the third question, C question. This C question is almost like the first one. So this is 3.0 minus 2.1, which will give us 0.9. And 0.9 happens to be greater than 0.5, but in between 0.5 and 1.9. So this is a polar covalent bond. This is polar. So this is polar. Now for this question is in your past question, so we are solving your past question. Now they say iodochloride. So iodine, I believe, with chlorine. Notice that this particular question does not look balanced. It's not balanced, but it's just for us to find what we are given. Now if I have this, I will now have that. In this case I have 2.5 and I have 3.0. So when I minus this, so solving this 2.5 minus 3.0, solving this, notice that whenever the negative sign is before a greater or a larger number, to carry minus. So this will be minus 0.5, and minus 0.5 is definitely less than positive 0.5. So this is a non-polar covalent bond. So it's non-polar. So we move to the last one. The last one says fluorine is 4.0 and nitrogen is 3.0. So when you do this, this is something as 1.0, and 1.0 is definitely more than 0.5, but it is in the range of 0.5 and 1.9. So this is a polar covalent bond. So it is polar. So let me write my solution. Now, so there you have it. That's my answer. So let's move to the last part. I have what type of covalent bond is formed in the following compounds. I have lithium chloride. So lithium chloride, there you have it. And I'm giving lithium to be 3.0 minus, I'm giving chlorine to be 1.0. And if I have this value, it's not steady. Whatever they give you is what you work with. This will give me 2.0. and 2.0 is above 1.9. 2.0 is above 1.9. So that means that this is an ionic bond or ionic bonding. That means that this is an ionic bonding. So this is my solution. This is an ionic bond. Now the last part say, what is valency? Valency is like a rank, or you say it's money. When you want to buy something, they tell you what do you have. So something to show that you can combine. So that is why we say the valency of nitrogen, for example, is 5 and 3, because it is having 5 in the outermost shell. So when you are doing the Lewis, it will always be 5. But when they ask you how many electrons does it need to attain octets, it's 3. So you see it. So the combining power of an element is called valence. Valency is the combining power. Combining power of an element. Combining power of an element, or you can say it is the number of electrons in the outermost shell. So whichever way it makes sense to you. Thank you very much. Remember to like, share, subscribe. Academic Daddy. So whichever question you have, always remember to post it on the comment section. Those of you with my number, you send me DM of the question and it will be solved. Thank you.